Here I have two examples, one dealing with finding the area of a sector, and in the next one I'm going to find the area of a couple segments in a circle. So the first one, I want to find the area of the green sector. So I think back to my formula. Area equals n divided by 360 times pi r squared. And I look up here and it tells me the radius is 5, so that's going to be pretty straightforward. I can put that in for r right now. And then n, remember, is the measure of the angle that creates the sector, or it's the measure of the arc that creates the sector. Well, I look at that and it's right here. So I can put that into my formula as well. 135. And then the rest of it's already done for me. Divided by 360 times pi r squared. And that's going to give me the area of my sector. So now it's just a matter of simplifying kind of what I refer to as the mess. Well, 135 divided by 360, if we simplify it, that's going to be 3/8. So we have 3/8 pi, and then 5 squared is 25. I'm going to just look at this without using a calculator and multiply my fractions. 3/8 times 25, well, 3 times 25 is 75, so I'm going to have 75 times pi eighths. And there would be the area of my sector. Now I need my label, which is inches squared, because I look up here and the radius was in terms of inches, so my area is going to be inches squared. Here's the exact area of my green sector. Now if I wanted to come up with the approximate value of my sector, I'd have to type that in on my calculator. And after I type it into my calculator, I end up with approximately 29.45 inches squared, or square inches. So I have both of my answers there, the exact area right here and the approximate area right here. Now my next one, I want to find the area of the segments of the circle, called the shaded regions. So these two little green spots. And there's a couple different ways to go about calculating this area. I'm going to look at probably the longer method here, because that will work to find the area of any segment of a circle versus just when you have a regular polygon inscribed in a circle. So what I'm going to do first is I'm going to break it up, and I'm going to look at just calculating the area of one of those segments of the circle. And once I have one of them, I know they're congruent, so I'll just multiply by 2. Now to do that, I'm going to connect the endpoints of the segments of the circle back to the center of the circle. And what I need to know to be able to calculate this is I need to know what's the measure of that angle that I just created. Well, being this is a regular hexagon, I know I can take 360 and divide it by 6, because if I were to put all of these segments that go from the center back to each vertex, there'd be 6 angles around the center. And then my 360 divided by 6 would be 60 degrees. I know that angle in there is 60 degrees. So I'm just going to put that right here. That would also be the measure of the red angle. And I'll show you in a little bit why I didn't get rid of it. Now, what I can do is I can use that to calculate. Actually, I'm going to do this. I'm going to put it in here as well. To do that, what I'm going to do is I'm going to calculate the area of the entire sector right here. So this whole thing, I'm going to find the area of it. Now that's granted going to be too much, but then what I'll do is I'll get rid of the area of the triangle. So I'm going to do the area of my sector. It's going to be n, which in this case is the 60 degrees. Then I have to divide it by 360, so I'll figure out what fraction of the circle I'm calculating the area, then times pi, and then the radius squared. Now I don't necessarily have the radius right now, but I'm going to be able to figure it out here pretty fast, because it tells me the diameter is 12 centimeters, which then tells me if I take the diameter, cut it in half, I'm going to have the radius. So the radius of my circle is 6 centimeters. I can put that into my formula then, 6 and then squared. Remember, n divided by 360 times pi times the radius squared. All right, let's simplify this. So the area of what I have there shaded, the purple sector, well, I'm going to do some simplifying. Well, let's do this. Kind of talking too much and thinking too much and not talking enough. So 6p divided by 360, simplified would be 1/6. So I have 1/6 pi times 36. Now my 6 and my 36 will simplify, and all that's left then is 6 pi for the area of that purple shaded region. But now that's way too much. I only want the green part. So what I have to do now is I have to get rid of the area of this triangle. Now to do that, I need to know how long is the base and how long is the height. Well, I'm going to look at this triangle, and I already know that one of the angles is 60 degrees, buried way underneath there. And I also know that it's at least isosceles because this side of the triangle is 6 centimeters long. But then the other side, this will also be 6 centimeters because it's a radius of the circle. And now that I have that, and I know that I have the 60-degree angle, I know that these two angles down here are going to have to be congruent. Well, if the one I know is already 60 degrees, that leaves 120 degrees left for these two angles. And if they have to be congruent, I'll divide by 2 and find out that that's a 60-degree angle and that's a 60-degree angle. So I have an equilateral triangle, which, if it's equilateral, means all the sides have to be congruent, and now this side has to be 6 centimeters as well. So I think about this, and I have a base now. I can use any one of these. I'm going to use this one as my base. And then I just need to know what's the height. So I'm going to come back here. I'm going to put in my height, which would be right here. And remember now, in an equilateral triangle, if you put the height in, it's going to take that triangle, it's going to cut it in half. So I have this triangle here that's cut in half. It's going to be a 30, 60, 90 triangle. Which then means, I'm going to take this, I'm going to move that out. That means that this part right here is 3 centimeters. That's the short leg in my 30, 60, 90 triangle. Well, then the long leg is the height of the equilateral triangle. That's going to be 3 root 3. And I know that that's probably a little hard to see. Maybe I should just take it and bring it out. So that part right there goes in, oops, and that's the long leg, or that's the height of my triangle. Now I look at the big equilateral triangle there. I know the base, it's 6 centimeters long, and I know the height is 3 root 3 centimeters long, so I can find its area. I'm going to do this. This was the area of the sector, and now I'm going to do the area of the triangle. So 1/2 times the base, which is, remember, 6 centimeters, times the height, which is the 3 root 3 centimeters. Multiply this all together, and I'm going to have the area of my triangle. I'm just going to go like this. That's going to become 1. That's going to become 3. And I end up with, oops, excuse me. Did not do that right, did I? I'm going to have 3 times 3 is 9 root 3. Now remember, thinking back, I said if I could find the area of the big sector, which I had as purple, and it's really hard to see because I have it all colored in, and I had the area of the triangle, I could just subtract them to get the area of that one green segment, excuse me. So here was the area of my sector. So I'll take that, 6 pi, but then I have to subtract the area of my triangle, which is 9 root 3. So right there, that is the exact value for the area of just one of those green segments of the circle. Now there's 2 of them, and they're congruent, so I'm just going to multiply by 2, and I'm going to have the area of my green segments of the circle. I'll end up with 12 pi minus 18 root 3 centimeters squared. This is the exact area of it. Now, that's a pretty hard number to look at and to be able to understand, well, how big is it? So what I'm going to do is I'm going to punch it on my calculator and come up with the approximate value. That approximate value comes out to be 6.52 centimeters squared. So now, yes, I know there was a lot involved in that problem, but what I want you to remember is they're all little things that you've done in the past. And just kind of remember what I did here. The first thing I did, to review, I found the measure of the angle that created one of the segments of the circle. It came out to be 60 degrees. Now sometimes that'll be given to you and you don't have to do that. That would be nice. After that, I went through and I found the area of the segment, or excuse me, the area of the sector of the circle. So this number right here, way too much. And then I realized, well, I have to get rid of the triangle. So I went through, found all the pieces I needed to for the area of the triangle. And then once I have the area of the sector and the area of the triangle, I can subtract them, and that's what I did down here, to give me the area of that one segment of the circle. Now, this problem was special because I had two segments that were congruent. That's why I multiplied by 2. Sometimes you only have the one, and then you just need to do the purple minus the pink. But in mine, I had to add 2 of them, so I had to multiply by 2. I had my final answer as an exact answer, and then final approximate answer. And that's going to conclude my examples on areas of sectors and areas of segments of circles.